Let's set this up to move on. We want to get past the stories. Stories are nice. They don't tell us what's true, what's happening. So what we're going to do here in chapter 2 is we're going to start to figure it out. We're going to map it. We're going to talk about angles. Very critical, I'll show you. We're going to map your sky standing outside. We're going to map Earth, so where you are as you look up. And we're going to map what we see, the stars, okay, and planets, and so on. So that's what we're going to do. Let me show you what that means. Angles are wedges. You can go like this, make a bigger angle, a smaller angle. Right? You can use a protractor to measure angles. An angle is a wedge. How big a slice of pizza do you get? Right? A wedge. How big is the angle? And we can measure that. When you look at two things, you point at one, you point at the other, you swing through an angle, don't you? So we'll talk about angles and review that. If it's familiar to you, fine. If it's not, that's fine too. When we talk about your sky, or when I talk about your sky, I'm talking about you standing outside here, hanging out with your sheep. I need sheep. I don't know what happened to my sheep. Here's my sheep. I got an alien sheep, whatever that sheep is. And here's a sheep. And you're out in the field, and you want to point to something. So you got to turn around and look up. And you want to map your ground. I could even say map your ground in your sky, right? So what do you see just standing here? You don't see the whole Earth. But in reality, of course, we know that we are on an Earth. And so where you are on Earth, here's a small one. If I want a bigger one, I can have a globe like this and say where I am on Earth, and as it spins around, it will affect what I see in somewhat of a complicated way. So we'll just get a taste of this. Map your sky outside, tell someone where to look. Map Earth so you can see where you are. And then we're going to map the stars, all those things way out here. And of course, stars, as you know, are the close stars in our galaxy. Let's talk about that for a second too. As you move forward, always review. Eat sandwich, drink wine. Always review. And we're going to do a quick review and lead to this. So remember that we had lots of stories. People wondered about things. What's going on? And they looked up. And chapter 0 was stuff that people didn't know for most of human history. And even now, most people don't know it. Twofold. One is because it's a crazy idea, so you have to study it some and read chapter 0, study chapter 0. And also because we're busy doing other things. We're not as tied to observing the sky. This was not known in chapter 1 with our ancestors. But in chapter 0, we talked about AUs and light years and millions of light years and billions of light years. What exactly were we talking about? So let's get a sense. We're going to work on this, right? So the distance from sun to earth on average, we'll get into this more in chapter 3, we call one astronomical unit, 1 AU. That's average. Now not exactly, but about 93 million miles, okay? That's a distance. Now, this scale is completely wrong. I mean, Earth would be so tiny, you can get 100 Earths across sun, 109 if you want to be picky. And so it's just a drawing, right? But this brings up an important point about how we get past our stories. If you're tired of just making up stories or listening to your parents or your grandparents or all the stories, and if you want to know the way it is, you got to look. So we got to start drawing pictures. We draw this picture, and it turns out it takes 8 minutes for light to travel 93 million miles. Light's very fast. You'll get into that. We'll say that over and over. Also 8 minutes to hit moon, because moon's right next to us, really. It's really right there. When it bounces off Moon, it takes 1.2 seconds. That gives you a sense of how close Moon is compared to Sun. A number you'll learn later, I'll just lay it in, this is a preview of things to come. Sun is about 400 times farther away than Moon. In fact, if you multiply this times 400, you get about that. So that works out nicely, that's true. So that's our little neighborhood, our little bit. But really our whole neighborhood includes our solar system. Well, what's our solar system? Let's go back. Let's go back for a second. We're just laying the groundwork here, and then we'll move into chapter 2. Okay. Remember, the universe has about 100 billion galaxies, 4 general shapes, and each with, you could have a billion stars, you know this, 10 billion stars, 100 billion stars start getting big, right? 1,000 billion stars really big. We're in a barred spiral galaxy called the Milky Way, or our Milky Way. We're about halfway out, and that's our solar system. The little dot, I can't even draw it small enough, is our sun and all planets, including Pluto. Right? And we look out and we just see the close stars. So it's a crazy idea, but with telescopes, 100 years ago, we discovered there's galaxies, and now we know more about that. So here we are looking right there. We have our star, Sun, which is about 1 AU away. We're going to study more about that, so we're not done. We're going to build. Right. Pluto is, on average, 40 AU away. Sometimes 30, sometimes 50, but it's about 40 AU. So that means it's going to take 40 times 8 minutes. You can calculate that or whatever, but it's about 5 hours. So even a radio signal, which is light, a form of light, not visible, will travel, it'll take 5 hours to get there. So if light travels for 5 hours, it goes from Sun to Pluto. But what if light travels for an entire year, not 5 hours, not 24 hours, not a week, not a month, but a whole year? Light keeps traveling these distances. So the distance to Pluto, about 40 AU, let's just say for now. The time light takes, 5 hours. The thing that's a little bit funny about the light year is light year is a distance, and yet it says year. Year is a time. After light has traveled a time of 1 year, it just keeps going. It just keeps going unless it hits something or whatever. After it's traveled a time of 1 year, it has traveled a distance of 1 light year. If it's traveled 300 years, it's traveled a distance of 300 light years. It's crazy that it can do that. I mean, that alone is crazy. A distance of 1 light year is about 1,500 times farther than Pluto. I'm not going to give you exact, just rough numbers, easy to remember, right? I mean, Pluto's already way out there. It took us 9 years to travel there with a spacecraft. Too many numbers. So write down the basic numbers. I do want people to know that 1 light year is about 63,000 AU. It's a lot farther. And yet we don't even get to the closest star. The closest star being 4.2 light years away. It means light has to travel. So it's pretty darn crazy. Right? I mean, it's pretty crazy. And yet, we go back to chapter 1 and our ancestors, and we look up and we map things and we watch things, see what we can see just with our naked eye, not knowing any of this stuff. And people make up stories, and sometimes they make up stories in patterns so that they can keep track of those patterns. Not that the story means anything, but it helps you remember it, right? And so that's very useful. That's great. And our ancestors did some pretty amazing stuff, but they didn't have much equipment. So the way we get past the stories and arguing whose story is right, which is really silliness, right? Because they're stories, is to map things, to measure things, right? To measure the angle between things when we look. We do the best we can to inch forward. A lot of the knowledge we're talking about, we just know that very recently. But how did people get past that? We started mapping things out. And so too, we're going to map things out in chapter 2 and begin to make some distinctions and awareness and see how it was that people, as they mapped better and better, more and more carefully, came to discover what is true, independent of what story you want to make up about it. So that's what we're doing. We're bridging here. We're going from observing with our naked eye and making up stories to starting to map it out, which people did a long time ago. They did a good job. I mean, it's impressive, but still a lot they couldn't know. And then in chapter 3, we're going to go from 2,000 years ago to about 300 years ago with Isaac Newton and the scientific revolution. And from 300 years ago till now, the advances of knowledge were crazy. And around 1900, 100 years ago, our knowledge of the very small of atoms and the very large of galaxies blew up. And then technology, et cetera, in the 1900s, and our knowledge came. So this is a course of history that's profound. And where do we go back to? Mapping. Map it out as carefully as you can. We'll also see it affected politics.